Let's do some logarithmic equations. When you solve logarithmic equations, it's important to keep in mind that the log function, when you have log a of x, the domain of log is for only positive values, so x has to be positive. Okay, you can't put negatives inside the log. And the limitation for a doesn't come up often, but it's still important to know. This value of a cannot be negative, of course, but it can't be 1 either. So either it's bigger than 1 or less than 1. It can't be 1. And it has to be positive. So this requirement that x has to be positive will show up later. Let's do the first example. Example 1, let's say you have log, the natural log of x minus 3 equals to 2. What would you get? Well, just like when you solved the exponential function, you took the log with the same base to cancel the exponential function. This time when you see a logarithmic function, the idea is to cancel the log function by exponentiating. But then you have to remember what ln means. ln means log with base e. So you can rewrite the above equation as log base e, x minus 3 equals to 2. And now you can exponentiate both sides as over power of e. So that e and ln cancels, and you end up with x minus 3. On the right side you have e squared, and finally you have x equals to e squared plus 3. E is some number called the natural number 2.718 something. Okay. So that wasn't too hard. Let's do a slightly harder example. Still not that hard. Example 2. You have example 2. What if you have 3 minus log 2 of 5x equals to negative 2? How would you solve this? Okay, then the solution is you have to subtract 3 both sides. So let's subtract 3 both sides. So you get negative log 2 of 5x minus 5, and then you divide by negative 1 both sides to get log 2 of 5x equals to 5. Okay, now we need to solve this for x. To solve for x, it means I have to get rid of these log function and 5 and all that. So we really need to get rid of this log of 2. How do we do that? Well, we raise it over the power of 2. We exponentiate both sides by 2, and because you're treating both sides fairly, the result of this exponentiation should still be equal. So even after exponentiating by 2, they should still be equal. And then 2 and log of 2 cancels, which gives you 5x equals to 2 to the 5 power. Okay, what's 2 to the 5th power? Well, you can compute this as 2 to the 5th power is 32, and therefore x is equals to 32 divided by 5. That's the answer. Okay, in all these questions, however, I forgot to say that you have to plug it back in there to see if it violates any of the requirement about the domain. Had this answer became negative, then that answer should be thrown out and this equation would not have any solution at all. But this is positive, so you can plug into log, so that it really does give you a solution. Same with the previous question. The previous question had the solution as e squared plus 3, and if you plug it in here, you get e squared, so it does satisfy the equation. So for these, it's not a problem. Now let me show you this third example where the domain really does give you some trouble. So example 3, you have example 3. Let's say you have log of x plus log of x minus 3 equals to 1. What's the solution to this? Alright. Now, you first have to remember that log without anything under there means it's the common log, log base 10. So in order to get rid of the log base 10, you think you want to exponentiate both sides by 10, but if you just exponentiate by 10, this 10 and log 10 cannot cancel because there's another one here. So it's, see, this cancellation law, 10 with log 10 of x cancels. Doesn't work if you have log 10 of x and another something here, and if you have 10 here, these two logs cannot be canceled if there's the presence of another one. And therefore, in order to cancel the log 10, what you have to do is you first have to combine these two into a single log. So what you're doing is you're doing the opposite of the splitting rule. So remember, when you have multiplication inside the log, you can split the log into two. Now you can do the opposite. If you have two logs with the same base and it's added, I can combine it as opposed to chopped off logs. When you split logs, you can't combine them again except for a very strong glue. I'm not sure if you have such a glue, but you can actually put them together again to a single log like this. And only after this you can exponentiate with respect to 10 to get rid of this log 10. Now we've successfully gotten rid of this 10. On the right side we have 10, and this one, if I expand by multiplying them, x times x is x squared, x times negative 3 is negative 3x, so you have this equation. Alright, so let's see what you can do with this equation. First, I can bring the 10 to the other side and get x squared minus 3x minus 10 equal to 0, so that you get x minus 5 times x plus 2. That's the way it factors, and you get x equal to 5 from here, and x equals to negative 2 here. Now wait, one of these is not an answer. Can you guess which one? Look at the original equation. If you guessed that negative 2 is the illegal value, you guessed it right. So negative 2 is not good, because if you start plugging in negative 2, you immediately get a negative number inside the log, so that violates the domain of the log. Logs can only take positive values. 5 is okay. If you plug in 5, this is positive, 5 minus 3 is positive. In fact, you can check that log 5, and 5 minus 3 is log 2, and if you combine them, that's equal to log of 5 times 2, and since log without anything is log base 10, and 5 times 2 is 10, which is 10 to the first power, you do get equal to 1, which does verify this. So you can think of this as a check. I checked that this is true, so the only answer is x equal to 5. Now I want to show you this last example, which is my favorite question. Suppose you have log with base 3 of x squared and log with base 3 of x and the entire thing squared. And we want to solve this equation. Now at first sight, you may think, what's the difference? Well, it is very different, because this is, you square first and then you take the log, whereas on the right side you take the log first and then you square it, and they're actually quite different. In fact, this 2 is exponentiating everything inside the log, and therefore you can jump over the log. This 2 can jump over the log like a frog, so I can make it jump over the log like a frog, just like this. Whereas on the right side, this is squaring the entire thing, and squaring and multiplying by 2 is not the same thing. So this 2 is not the one that can jump over like a frog. It's just stuck there. It cannot come come down. Okay, so to explain this again, only the exponents inside the log are able to hop in front, but this cannot. Okay, let's look at this equation for a moment. This is log of 3 of x, log of 3 of x is squared, and this is multiplied by 2. They're clearly different. Times 2 and squaring aren't the same. But since I see log 3 of x in both cases, I guess a nice approach is to come up with a change of variable. Remember, when you do a change of variable, don't get too excited when you get the answer. You have to go back to your original x. Okay, let's subtract 2t both sides, so you get 0 equals to t squared minus t, which factors as t times t minus 2. Therefore, the only way that this could be 0 is when t is 0 or t is equals to 2. Now, what does that mean? In terms of the log 3 of x, we have two cases, log 3 of x being 0. I can exponentiate both sides by 3, so these cancel and you get x. Anything to the 0th power is 1, so that's the answer in the case when t is 0. The other case is when log 3 of x is equals to 2. I can exponentiate both sides by 3, cancel, and you get x equals to 3 squared, which is 9. So the final answer is 1 and 9. Now you should go back and see if there's any problem in plugging these numbers, and these are all positive inside the log, so there's no problem with the domain issue. So both of these indeed become solutions of the original function.